So, hello everyone. Today we are back with another problem of the day question on lead code. The problem of today is binary tree zigzag level order traversal. It's a medium level question on lead code. So, let's read the problem statement. Given the root of a binary tree, return the zigzag level order traversal of its node values. That is from left to right, then right to left, and alternate between. Okay, so the question is telling us that we need to return the level order traversal of this binary tree, but we should do it in alternate way in each level. For example, in this level we are moving from left to right, then in the next level we need to move from right to left, and so on. So let's start writing the code. First, let's have a vector of vector since we need to return it as an answer. So let's name it answer. And we'll check the base condition that if roots equals null, then in that case we simply return the empty answer whatever it is at present. Then since we need to do level or traversal and we need to keep track of each level, we'll have two stacks and that are going to store the address of tree nodes variables, and let's name them current level and next level. Then we can push our current root into our current level, and we also need to check whether we need to move from left to right or right to left. For that we can keep track of a boolean variable, and since we need to move from left to right in the first go, so let's name it left to right and set it to true. Then we'll need to have a while loop that will run till our current level stack is not empty. Once we come inside loop, we'll take out the element or the node which is present at the top of our current level stack. So let's take it out. Let's name it to x, and it will be current level dot top, and we need to also pop it down from our current level stack. So current level dot pop. Once we are done with that, since in the next level, for example, we are present at here, so we'll also push the value of that x node into our temporary vector, which we also need to have to store our traversal for each level, right? So let's name it temp, and let's push the x value into our temp vector. And once we are done with that, since in the next level we need to move from right to left, listen this very carefully. In the next level we need to move from right to left. So for moving right to left, imagine in the stack, if we need to move from right to left, then the rightmost element should be present at the top of the stack, and the two, and I can say is to have rightmost element at the top of this stack, it should be pushed at the last, because stacks follow first in last out strategy, right? So we'll have if our left to right is equals to true, it means that in the next level we need to move from right to left, and if we need to move from right to left, then rightmost should be present at the top. So we'll push the left first and then right. So we'll check if our temp with it will be x. If x left is not equals to null, we'll push it into a next level, x left node. Then we'll check if x right is not equals to null, then we'll push the right one into our next level. So right. Hope you understand it. And similarly, we'll check if our left to right is equals to false. Then in the next move we need to move from right to left, right? In since left to right is false, so in the next iteration we need to move from left to right, right? So we'll do it opposite. We'll push the right one first. So we'll check first if x right is not equals to null. Then we'll push whatever be x right first, and similarly we need to check for x left also. So hope you understand this, what we are doing. And at the last we'll check if our current level is empty. Dot empty. If equals to true, then we'll come inside, we'll swap our current level and next level, we'll push our temporary vector into our answer. We'll also clear our temporary vector to store the further levels, and we also need to swap, or I can say change, the boolean variable to its alternate. So left to right will be equals to not left to right. So once we are done with that and we reach the end, we simply need to return our answer. I hope we are doing everything right. I have not made any typos. So let's run this code. Okay, so it's accepted. So let's submit it. And yeah, our solution is 100% faster. So I hope you like this video, and if you love this video, do like it and give it a subscribe. We'll back with another problem of this statement in the coming videos. Thank you.